Hello everyone. In this video, I'm going to explain about a network testing tool that is T3 tool, stands for TCP Throughput testing tool, developed as a part of Genesys by CDAC Hyderabad. And now, before we start the test, let me briefly explain you about the tool. This tool compliant with RFC 6349, which describes a practical methodology for measuring the end-to-end TCP throughput in a managed IP network. And now we'll go through some of the features of this tool. This tool can emulate multiple sessions, and it has got a GUI which displays the result of every test. And one important feature is all the tests are automated just after the click on a button, and finally at the end it generates a PDF report of the conducted test. And now we'll talk about some of the application areas of this tool. Recently this tool has already been deployed on the NKN to test the network, and it can efficiently be used to test similar high-end networks like NOFN, BSNL, etc. And the network providers can also use it to verify their network before they provide it to the customer. And currently the tool is deployed in Genesys lab to test a 10G network setup. Testing. Now, the first thing what you have to do is we have to provide some inputs to the GUI of the tool, like server's IP address, port number, Ethernet interface name, and some SLA informations provided by the network provider. So we'll provide these informations in the GUI. And as currently we are testing a 10G network, so we'll put 10G network setup. And then firstly we have to ensure the network connectivity between two end hosts by running the network alive test. So we'll run the network alive test first. And what it is showing is network alive test is successful and destination is reachable. So there is no problem with the network. So we can move forward and start the test. So we'll start the test now. Now the first test is identifying the path MTU of the network, which is the maximum transmission unit, which identifies the maximum size of the packet which can flow in the network without being fragmented, so that our throughput can be maximum. The next test is identifying the round trip time of the network. It will be started. So this test identifies the round trip time of the 1500 byte packets from the client side to the server side, and the identified round trip time would be shown in these blocks: the minimum, average and maximum RTT, and the average RTT comes out to be 264 microseconds. Then comes the next test, which is bottleneck bandwidth test, which identifies the maximum capacity or the maximum bandwidth of the network, which is coming out to be almost 10,000 Mbps, as we are testing a 10G network, as I have told earlier also. So at the end of this test, meter will display the bottleneck bandwidth. This test is of around 30 seconds. So the bottleneck bandwidth is 9850 Mbps, which is about 10 Gbps. And then starts the window test. Actually what happens is, when a TCP connection is established, a receiver advertises a window size which controls the flow of data in the network between two end hosts. As RTT and bottleneck bandwidth is already identified, so what we'll do is we'll use them for calculating the BDP of the network, but bandwidth delay product. So the window size should be kept equal to the BDP to achieve the maximum throughput. Window test is designed to calculate the throughputs at different window sizes for single and multiple connections. Right now single connection test is running. and then multiple connection test is started. It will also take 4 iterations. Like single connection test, window size is varying and connection is single only. In multiple connection test, this is for one connection, this is for two connection, and window size is kept constant. The same test will run for the downstream. This is for upstream, like client is sending data to the server. Now downstream test will start. In that the server will send data to the client. It is started. In this, BDP is different from the upstream one, because RTT is different from client to server and server to client. It is different for both. So this test will also take 8 iterations. Currently single connection test is running. Like BDP is divided into 4 parts. So we are calculating the throughputs at different window sizes at single connection. Now starts the multiple connection test. And then finally throughput test is started. The GUI is showing 4 graphs. The first one is TCP throughput graph versus time intervals. Like this test will run for around 60 seconds. So every second the throughput is being shown by the display. Currently it is coming around 10,000 as we are testing a 10G network, and as retransmissions are 0, so there is no fluctuation in this. This is a link throughput graph which tells the throughput at the interface, and this is a TCP throughput graph which tells the throughput at the layer 4, like protocol throughput it is showing. This one is the RTT graph which is showing the RTT at full load, and this is the complete summary of the last test. So window size is kept equal to around 3 lakh something thousands, and this screen is showing 3 matrices. First one is transmission efficiency, which is coming out to be 100% because retransmitted bytes are 0. Second one is buffer delay, which is came 87%, which shows the increase in the round trip time as compared to the baseline RTT. And the third one is transfer time ratio, which gives the ratio between the expected transfer time and the actual transfer time. These two are the link throughput and the TCP throughputs. And then the same test will run for downstream, like server will send data to the client. That will also take around 60 seconds. This has also got the same graphs as shown before. Here also retransmission is coming out to be 0. RTT has increased a bit because of traffic. And TCP throughput is always a bit less than link throughput. It is finished now. The summary of this test is shown on this page. Same matrices are calculated. Transmission efficiency is 100% this time also because retransmitted bytes are 0. Buffer delay is 55%. and TCP transfer time ratio is 1.0070. Now this tool has also got a feature of generating our own report in PDF format. So we'll generate our report. T3 report, PDF format, and we'll save it. That's it. And this is the generated PDF report file of the test conducted. It includes all the test related informations, all the test results in detail in graphical as well as tabular format. And at the end, it has also got a summary of the complete test. And this completes our TCP throughput testing tool.